To divide a polynomial by a monomial, we're going to separate this polynomial right here with each monomial. So the 6x fourth y3 is going to be divided by 3xy. And then I'm going to go by 12x cubed y squared over the 3xy. And then my minus 18x squared y over my 3xy. Now I can do each one separately. So I divide my numbers. 6 divided by 3 is 2. I subtract my exponents. 4 minus 1 is to the third power. 3 minus 1 is to the second power. So there's my first done. Then I divide 12 by 3, which is a positive 4. And I subtract. So x, 3 minus 1 is 2. 2 minus 1 is 1. And then I divide my numbers. Negative 6, x minus 1 is x, and y divided by y is really just 1, or the 1 minus 1 is 0, which gives y to the 0 power, so there's nothing written there. So this is my answer, dividing the polynomial by a monomial. Now if we look at this next problem, it looks a little different, but it's only written different. This part right here with the negative exponent means to flip that part. So in reality, this is 18x squared y plus 27x cubed y squared z, but it's all over the 3xy. That's what the negative exponent means to do. I'm taking that part and flipping it to the denominator. Now I can do the exact same thing. So if I did in the previous problem, I separate each monomial and divide each one by 3xy. So if I divide 18 by 3, I get 6. I subtract my exponents. X, y cancels. 27 divided by 3 is 9. Subtract, I get x squared. I subtract, I get y. And then z doesn't subtract with anything, but it doesn't cancel out either. And so then I have my answer. All right, so to do these division problems, we're going to do what's called long division. And so I'm going to take what it's being divided by, x minus 3, and I'm going to divide, let me erase that here, we're going to divide, I'm using a long division sign, divide by what's in the parentheses, 7x minus 30. So to do that, I'm going to take my first variable, and I'm going to look at the first variable, and whatever is missing, so I have x and I have x squared, I'm going to write on top. I'm missing one x, so I'm going to write the x. Then I'm going to multiply, so x times x is x squared, and x times negative 3 is a negative 3x. Then I'm going to subtract. X squared minus x squared is 0, so that's nothing. But 7 minus a negative 3 is actually a 10x, and you can do that in your calculator. Then I'm going to drop down the next number, which is a minus 30. Now I'm going to do the same process. What in this first term is missing from this? It has an x, but it's missing a 10, so I'm going to put a positive 10. And then I'm going to multiply. 10 times x is 10x. 10 times minus 3 is a minus 30. And so once I do my subtraction of this one, I get 0, and I also get 0 for this one. And since I have a remainder of 0, my answer is x plus 10. So x plus 10 is what x minus 3 divides into. And there's my answer. So let's do the next one, do long division. So my x minus 1, I put on the outside of my long division, and I put what I'm dividing into and inside quotient. And so I look at the first x, what's missing to x squared? Well, I'm not missing an x. So then I multiply. X times x gives me my x here. Basically what I'm trying to do is create where I can subtract to get 0. And x minus 1 is a minus 1x. So now I'm subtracting. These two go to 0, but this one does not. It goes to minus 13 minus a negative 1 would be a minus 12x. And then I bring down my next number. I do the same process. What's missing from the x to a negative 12x? The only thing missing is a minus 12. So I multiply minus 12, I get minus 12x. And minus 12 times 1 is a positive 12. And when I subtract those, notice I write the subtraction sign. These go to 0 and 0. And so my answer is x minus 12. X minus 12.